All right, this is our video lesson on rationalizing denominators, which you'll see is really the same thing as dividing. Uh, excuse me, is the same process as dividing complex numbers. So we're actually going to start with an old problem from lesson 3.2, which was divide 16 plus 11i divided by 2 plus 3i, and we discovered that um, if we multiply by the conjugate of the denominator, top and bottom here, 2 minus 3i. Just a reminder, the conjugate is when the middle sign changes. The 2 plus 3i becomes 2 minus 3i. What will happen is very nicely in the bottom, you will get a nice, neat number, like a real number in this case. And we're going to actually apply this process to radicals in the denominator. So just bear with me here. So in the top left, 16 times 2 is 32. 16 times negative 3i is negative 48i. 11i times 2 is positive 22i. And 11i times negative 3i is negative 33i squared. All over. I'm going to multiply the whole conjugate out, and you'll see the cancellation that occurs. 2 times 2 is 4. 2 times negative 3i is negative 6i. 3i times 2 is positive 6i. And 3i times negative 3i is negative 9i squared. We'll handle the numerator in a second. The denominator becomes very nice because the middle two terms cancel. It's almost like having the difference of two perfect squares in a sense. If you were to multiply x minus 3 times x plus 3 out, you would get x squared minus 9. That's exactly what we have here. We have 4 and then minus 9i squared. Well, I squared is negative 1, so this is really negative 9 times negative 1, which becomes positive 9. So I have 4 plus 9, which is 13, for my denominator, which is fantastic. I've rationalized the denominator, made the denominator a nice number, an integer in this case. Integers are rational numbers. So on the top, we have a little bit more stuff to do. So we have negative 48i plus 22i, which comes out to minus 26i. I'm putting it here because we like to make things in a plus bi form. My I squared over here is negative 1, and negative 1 times negative 33 is positive 33. So now I have 32 plus 33, which is 65. And it so happens that these both numerator numbers divide, or 13 divides into them very nicely. 65 divided by 13 is 5. 26i divided by 13 is minus 2i. And so my answer here is actually 5 minus 2i. And if you look back at lesson 3.2, we actually, before we started this lesson, we multiplied 2 plus 3i times 5 minus 2i and got 16 plus 11i. All right, very similar process in number 2. So we want to divide 9 divided by 3 minus radical 3. Notice I have this irrational number in the denominator in the radical 3. We can multiply by the conjugate to get rid of that radical in the denominator, almost kind of transfer it to the numerator. So here we have 9 times 3, 27, plus 9 radical 3 in the numerator. The denominator, we know the middle terms will cancel. I'll multiply this out anyway, but eventually I think you want to get to this point where you can just do this in your head almost. 3 times 3 is 9. 3 times radical 3 is 3 radical 3. Negative radical 3 times 3 is negative 3 radical 3. And negative radical 3 times positive radical 3 is minus 3. So now we have 27 plus 9 radical 3 over, and you'll see again, just like the I terms canceled out before, the radical terms cancel out, and 9 minus 3 is 6. This can be further simplified. If you realize we actually distributed that 9 through, we could there's a few ways to simplify this. We could factor out the 9 on the top and be left with 9 times 3 plus radical 3 over 6, and then realize that 9 over 6 simplifies to 3 over 2. So I get 3 times 3 plus radical 3 over 2. That's certainly one way to write the answer. Or you can realize, this is another way to do this, or you can say, okay, I have 27 over 6 plus 9 radical 3 over 6, and 27 over 6 simplifies to 9 halves if you divide each guy by 3, and 9 radical 3 over 6 divides and simplifies to 3 halves. And then you could, if you wanted to, combine this into one fraction again. 9 plus 3 radical 3 over 6. This is, sorry, over 2. Whoops. This is fine. This is fine. Even this is fine. If I asked you to write it as one fraction, though, I would expect either this answer, answer A or answer B. And this is called rationalizing the denominator, because you've now made the denominator into a rational number. You have turned it into, from you had an irrational denominator and you made it rational, right? And you're not changing the value of the fraction, and I'll prove that to you. So here's our calculator. The original fraction, if you press alpha y equals enter on the 84s, you can get a fraction key, was 9 over 3 minus square root of 3, which has that as its decimal value. And we just got, for our answer, say we got 9 plus 3 radical 3 over 2, so alpha y equals enter again. I got 9 plus 3 square root of 3 over 2. And that is also 7.098. So those are equivalent values. Okay, good stuff. So let's say in number 3, I wanted to rationalize the denominator. Again, you can multiply by conjugates here. You just got to be careful, I suppose. You want to multiply by the conjugate of the denominator, which happens to be 3 minus radical 5. Again, the goal is to rationalize the denominator. By the way, you can also rationalize the numerator. In fact, you have to do this in calculus sometimes. There's actually one of the problems in this group of problems that I gave you, kind of leads you. It's still a rationalizing the denominator problem, but it'll lead you to something nice when you get to calculus. You'll be able to see a little better and kind of more of what this really is about. Anyway, I digress here. So 3 times 3 is 9. 3 times negative radical 5 is negative 3 radical 5. Negative 5 times 3 is another negative 3 radical 5. These will not cancel. I hope you notice. And negative radical 5 times negative radical 5 is positive radical 25, or just 5. So you just got to be careful with your signs and such. On the bottom, I'm going to kind of go through this quickly because I see the cancellation. We have the conjugates. 3 times 3 is 9. Radical 5 times negative radical 5 is minus radical 25, which is just 5. Now in the numerator we get, let's see, 9 plus 5 is 14. So I get a 14 down there. And I get negative 3 radical 5 minus 3 radical 5, which is minus 6 radical 5. And 9 minus 5 is 4. And I wanted to show you this one because this one simplifies more at the end here. So a few ways you could do it. One way you can do it is to factor out on the top 14 minus 6 radical 5. We can factor out a 2. And I'm left with 7 minus 3 radical 5 over 4. And then I have 2 divided by 4 here, which simplifies to 1/2. So I would end up with a 1 in the numerator, a 2 in the denominator. 1 times 7 minus 3 radical 5 is just 7 minus 3 radical 5, and then divided by 2. That's one way to accomplish the task of simplifying it. Another way to accomplish the task of simplifying it is to actually write, you can write this as 14 over 4 minus 6 radical 5 over 4. You can distribute that division because basically it's multiplication by a quarter. And 14 over 4 simplifies to 7/2. 6 over 4 simplifies to 3/2. And then if you wanted to bring this back, so this should be a 5 here. And if you wanted to bring this back, that's a bad 5. Hold, please. So we have minus 3 radical 5 over 2. And I get 7 minus 3 radical 5 over 2 again. Whichever way you like is fine with me. And number 4, we don't have a binomial denominator. We have a monomial denominator. And in this case, you could multiply by the conjugate, which would be, in this case, negative radical 6. But you can also multiply by just regular radical 6. And you guys had done this in 8th grade. And you'll see very easily that we will get a nice rational denominator here. I will have 3 radical 6 in the numerator divided by radical 6 times radical 6 is just 6. And then I could simplify this further because I have 3 divided by 6, which is 1/2. So this is actually equal to radical 6 over 2, which is sort of an interesting equivalence. Again, you might want to see this on a calculator just so that you can be sure of it, because it does sort of feel strange, I think. So if I have alpha y equals enter, I have 3 over radical 6. I get 1.22, and then if I take radical 6 and divide it by 2, I also get 1.22. So they are equal, and there you are. All right, and one more for our video. Let's say I wanted to rationalize 3 over the cube root of 6. This is a little bit different. So you might be tempted to say, all right, well, I'll multiply top and bottom, not by the square root, but by the cube root. Now let's see what happens. Well, on the top, I get 3 times the cube root of 6 divided by the cube root of 36. The cube root of 36 is not 6 because we're talking about a cube root. Just to be sure here, again, cube root of 36 is the cube root of 6 times 6, which if you really wanted to factor this out, this would be 6 is 3 times 2. The other 6 is 3 times 2, so I get 2 times 2 times 3 times 3. There is nothing that I can triple up here. So the cube root of 36 is as simple as it gets. So we have not yet rationalized the denominator. Well, if I think about this a little bit more critically, 36 is really 2 6s. What I really need are 3 6s, and that'll do the trick. So I will multiply by another cube root of 6. And the reason for that is because now I will get 36 times 6, which is really 6 times 6 times 6. And then I will be able to simplify my my denominator radical into something that is not a radical. So on the top here, I'll get 3 times the cube root of 36, which remember does not simplify, divided by the cube root of 216. 36 times 6 is 216. But it's really the cube root of 6 times 6 times 6. Keep that in mind. And that's very useful because now this is the cube root of 6 times 6 times 6 is just 6. So I have 3 times the cube root of 36 over 6. And this can simplify as well. 3 divided by 6 becomes 1/2. So I get the cube root of 36 over 2 as my answer. Again, I'll prove this to you on the calculator, so you think I'm not doing voodoo magic here. So we have the original fraction was 3. Whoops, sorry, hold on. The original fraction was 3 divided by, and if you want to get to the cube root key, you press math, and it's choice 4. The cube root of 36 gives me this decimal. And now I want to take the cube root of 36. Sorry about that. Whoops. I want to take the cube root of 36, math 4, cube root of 36, and divide that by 2, and I will get the same exact answer. Now, again, the cube root of 36 does not simplify. I know that's tempting because 36 is a perfect square, but it is not only is it not a perfect cube, it's also not a number that can simplify because it's 2 times 2 times 3 times 3. The cube root of 36 is stuck in there. All right, so on this video, I just want to kind of run you through some of the problems. 6 is straightforward. 7 is straightforward, but you have some simplification to do at the end. 8 really comes from calculus. It's just with letters. My hint is do not multiply the numerator out. So when you're going to multiply the numerator by a quantity. Don't multiply that out. You'll get a very nice cancellation. Number 9 is straightforward. Number 10, you may have to think because I'm asking you to rationalize the 4th root of 2. 11 through 13 are challenge problems. These you have to think about. There's no necessarily standard algorithm for them that I want to give you. So in here, I'm asking you to rationalize a cube root binomial denominator. Number 12, I'm asking you to rationalize a trinomial, essentially, or fraction with a trinomial in the denominator. And number 13 is a fun problem. my hint is that you will actually get an integer answer for this question. All right, so enjoy. The homework, I will say choose any 5 problems you'd like to do out of the remaining ones. So if you don't want to do the challenge problems, you don't have to. If you'd like to do the challenge problems, that's great. All right, see you later.